Okay. So now the last idea that you need to know about complex, like the Argand diagram and complex numbers, etc., is the idea of locus, or the um, plural of locus, which is loci. Now,
Okay.
if you don't know the definition of a locus, you will need it if you go into engineering. Locus
Mm-hmm.
is essentially a set of points, that is basically is a path traced out by a point moving through, basically a point moving when it's following a particular rule. What does that mean? It's a bit hard to understand, but it's easy to visualize when you see it in a video. I'll send a video to you. But imagine it like this. Imagine that you have this equation, okay?
Okay.
And imagine it like this. You have a point sitting right here, and you're telling this point you can only take y values such that the y value is double the x value you're at right now. So when it ends up at, for example, when it's at -5, it'll be at -10. So because it's following the rule you set for it. And when it ends up at -4, it's gonna sit at -8, because again, it's following the rule that when I'm at x equals -4, the y value is gonna be the double of that. So it
Yes.
it keeps moving on this path basically, and it
Yeah.
has an infinitely many positions it can take on its path, because it could be at any x value and ever. All it needs to do it is follow this rule. So it's essentially gonna like make a locus. A locus is a set of points, essentially a path that is traced out by a point as it's following a particular rule that you set up for it. That's what a locus is. Loci
Okay.
is the plural of locus. That's basically it.
Okay, that
Okay.
makes
So this
sense.
line, the way you've been thinking about lines, you can think about them as a locus too. Okay.
Right. Okay.
So now what do we do? Um, the thing is, you could set up rules on the argand diagram in order to make interesting shapes. Okay.
Mm-hmm.
So drawing loci. I think loci is the singular and locus is the plural. Anyways, drawing locus on an argand diagram. So basically, when I say argand diagram, I mean the complex plane essentially.
Mm-hmm.
Now, we already know that a complex number is purely defined by an angle and a length, right?
Mm-hmm.
So we can define it like that at least. However, what if I make a rule, okay? I say that my complex number, all I want is every single complex number in the universe whose modulus, whose length is 5. I want every single complex number whose length is 5. This is a rule I've set. Do you agree?
Okay.
Now, think about it. I haven't specified the angle of the complex number. I don't care about the angle of the complex number. The argument, I mean. So
Mm-hmm.
if I only care about the length of the complex number, don't you think that every single complex number on this circle fits that description? Because the circle's radius is 5?
Yes.
Because I didn't set an angle. I only requested a length, which means that by setting this rule, I will essentially make a circle with a radius of 5 on my Argand diagram. Do you see the logic behind this?
Yes.
Yeah,
I
that's
do.
basically it. So by setting this specific rule, you've created a circle on the Argand diagram. So a
Mm.
circle, specifically a circle centered at 0, 0. Because again, I didn't say any rules that, somehow specify a different center. Okay.
Mm-hmm. Okay.
Now, what if instead I said that I want every single complex number whose length is less than or equal to 5. In this case, I would not draw a circle. I would draw a circle that's completely shaded in. Every single point in this entire region works because every single point in this entire region has lengths less than 5, right?
Okay.
And finally, I can also say that, I want every single complex number whose length is just less than 5 and not less than or equal to 5. In this case, I would end up with a dotted circle that's shaded in.
Mm.
right? Because I don't want the complex numbers on that line. I just
Yeah.
want the ones that are inside this circle.
Yes. Okay.
Are you kind of following what I'm saying?
Yes, I'm understanding everything.
Pretty, yeah, I think it's pretty easy to understand once you visualize it this way.
Yeah.
However, what if I'm trying to be fancy and I don't want to draw a circle at the center at 0, 0? What if I want to draw a circle that's centered somewhere else? Here's what I
Okay.
do. I say that I want so for example, let's say I want to draw a circle centered at, I don't know, like 3, 5. Okay.
Mm-hmm.
Okay. First, let's make a complex number point at 3, 5, which is, I guess, somewhere here. Okay.
Okay.
Now, do you agree that in order to make a circle that is perfectly, so draw a circle radius 1, okay? To
Mm-hmm.
make a circle of points who are all 1 unit away from this point, all I have to do is set a rule that I want all the points, all the complex numbers that are 1 unit far from 3, 5,
Mm-hmm.
right? And how do you find the distance? Like, how do you define the distance between 2 points? You say modulus, so the distance between z minus this guy basically. So 3 plus 5i. Every single point whose such that the difference between that point and 3 plus 5i, meaning 3, 5, is
Mm-hmm.
equal to 1 will be on this circle.
Right.
So by doing this, by saying that the distance between my complex numbers and this point is 1, I've created a circle centered at this point. So this basically is the center. Okay?
Okay. Mm-hmm.
So now to yeah, that's basically it.
Okay.
And of course, you can extend this by saying less than or equal to 1 and you'll shade the circle. If you say
Mm-hmm.
less than 1, you'll make a dotted circle, etc., etc. Okay? So the
Right.
idea stays the same. The point being, this is the rule that you need to make a circle that's centered somewhere else. Um, okay, let's talk about lines now. What if I want to draw a line? So instead of having my complex numbers in a circle, what if I want to make a line of complex numbers? So every single complex number that sits on this line. Okay, what if I want to do that? Let's see. So drawing a line. Okay. For instance, what if I want to draw this line? So this one. What do I do? Um, so let's think about this. So let's say that this is a fixed point that you know of, AB. Okay.
Mm-hmm.
And you want to draw a line from uh hmm, yeah. So you want to draw a line basically from, okay, wait, let me redraw this. It's better this way. 1 second. So let's say that you want to draw a line starting at this point
Mm-hmm.
and going, you know, in that direction, for instance.
Right.
All I have to do is I have to say that I want every single point in the world such that, for example, if this is a point that I want, I would require that the argument of the line that connects my point Z, my point Z with this point Z1, let's call it, with this point Z1 has to be exactly equal to this angle. So I will specify an angle like pi over 2 or pi over 3. So in this way, I've basically created a line from my initial point Z1 of
Mm-hmm.
every single point in the world such that the line that connects Z1 to that point is always pi over 3 radians from the x-axis,
Right.
from the horizontal. So this will create a line. Okay.
Okay.
So basically, if I want to make a general statement, if I create this rule, if I write down this rule, I will create a line from some point z1 with an angle of exactly theta degree or theta radians from the horizontal. Okay.
Okay.
This is a lot of information to take in.
Mm-hmm.
But once you see some visual examples of this, it'll make much more sense.
Yeah.
And there are a few other shapes that you can make, but I think for them the best option is to just learn them as they come in like past papers, because honestly I haven't seen a lot of Argand diagram problems in past papers recently. So
Okay.
I think this is a good enough amount of basically background for complex numbers. Now I
Okay.
highly suggest that focus on everything up to loci. Okay,
Mm-hmm.
not necessarily understand everything about locus, but
Mm-hmm.
it's good to just know the general idea. Because if you do get a question, it will maybe be 4 points at max. Okay, and it'll be
Okay.
like they'll give you a rule, like they'll write down this rule, and they'll be like, which of these following fit this rule that basically that we've drawn, or draw, the line or the region that satisfies this rule. That's basically it. Okay,
Got it.
and yeah, that's basically it.